Now we'll be solving this equation for the range. So when we calculated the escape velocity, this velocity of efflux, that velocity of efflux came out to be under root 2gh. So when this liquid goes outside, it follows the projectile path. So if it follows the projectile path, this is capital H minus small h. So when it follows the projectile path, either we can directly use the projectile equation or we can solve it one more time. So I'll prefer to solve it one more time. So when it is moving across a projectile path, it is falling down, and when it is falling down, meaning if I'll solve the equation along y-axis first to get the time, how much time it is going to take to land there. So along y-axis, first I will solve along the y-axis. If I solve along the y-axis, initial velocity along the y-axis is 0 because this v is along horizontal. So and acceleration along y-axis is g, it is downward. I am taking downward as positive, and the displacement along y-axis will be capital H minus small h. So we will use second kinematical equation. So that second kinematical equation, which is Sy is equals to uyt plus half ayt square. If we use that equation, so we put the values there. So capital H minus small h is equals to 0 into time taken by the liquid to go down, plus half g t square. So the value of t will be under root of 2 capital H minus small h divided by g. So that is the time this liquid will take to fall down, and obviously you see this time depends upon the small h. As we will change the value of small h, the time will take, this time will be different. For small h to be capital H, this will go to the bottom and the time will become 0 there. Okay, so this is the time this liquid is going to take. Now in this time, how much distance this liquid is going to travel? So for that, to calculate that, I'll solve the same equation, but this time along x-axis. If I solve the same equation along x-axis, we have to take the values of ux and ex and all. So if I solve along the x-axis, the ux is ve, and that value we have already calculated. Displacement along x-axis we have to calculate. Acceleration along x-axis is 0, and this time we know the time. The time in which we have to calculate the displacement along x-axis, that time is this one. Let's call it t0 for a time being, t0 and t0. So that is equals to under root of 2 capital H minus small h divided by g. That's the time. So we'll use the second kinematical equation along the x-axis this time. So that will be Sx is equals to uxt plus half axt square. Ax is 0 this time. So Sx, which we have to calculate, in this case it is the range. So r is equals to ux, which is ve multiplied with time, which is under root of 2 capital H minus small h divided by g plus 0, because ax is 0 there. So you see, if we put the values, the r will come out to be, we put the value of ve also, that value will become 2 times of under root small h capital minus small h, and this g and g will cancel out. So this is the range, and as you can see, this range depends upon small h. So this range is a function of small h. As we will change the location of the hole, the range will vary. Okay. So this time we also get the value of range as a function of h. Sometimes we are interested in calculating the maximum range, how much maximum range we can achieve. Examiner is interested in that. So we have calculated the range. To calculate the maximum range, all we have to do, differentiate this equation. Only one variable is there, small h, and this is a dependent variable. So if I differentiate this r with respect to small h, I'll get the value to under root small h multiplied with, if we differentiate the inside, this we have differentiate assuming under root x function, and if we differentiate the x now, it will give us capital H minus small h. Now for r to be maximum or minimum, we know that, we learned that in kinematics. So if we want r to be maximum or minimum, dr upon dh should be 0. So we put that value 0. If we put that value 0, that becomes h minus 2h upon under root h capital H minus small h, and that is 0. So obviously denominator cannot be infinity. So this small h will be capital H by 2. So we are getting one value. So at this point, if we make the hole at this point, in between point, the range is going to be maximum. or minimum also. Let's check whether this is maximum or minimum. So to check whether this is maximum or minimum, what we have to do, we have to differentiate this equation one more time, and then we have to put this value. That value you can do separately also. I'll tell you that value you can do separately also. So if we put this value into the equation, we will get the maximum range. So let's put that value there. So our max, if we will calculate, we'll put this value there. If we put this value, this will become capital H. That's the total height. So as you can see, we have calculated the V, then we have calculated V dash. We put the condition of this capital A being very large compared to small a. So V was depending upon H, and we know if this is a linear sort of linear function. So if H is 0, V is 0, H is max, V is max. Meaning if you are having this at the bottom, the V is going to be maximum velocity. But along with that, there is one more thing we were interested in, and that was the range. So if we calculate the range, we need VE, and what we did, we applied the kinematical equation along y-axis to calculate the time taken to land, and we applied the kinematical equation along the x-axis to calculate the range. And that range comes out as a function of small h. Meaning, if I keep changing this location of hole, the range will keep changing. So the thing is, this range was variable. It was depending upon the height, the depth of hole from the topmost point, or height of the hole from the bottommost point. So to calculate at what point the range is going to be maximum, for what point, what location of hole the range is going to be maximum, what we did, we differentiated. That's the mathematical method we apply generally. So we differentiated this function with respect to h. And after differentiating this function, we put it 0. And when we did that, we get the value of h to be h by 2. So that thing tells us that if I make my hole in between the topmost point and the lowermost point, my range is going to be maximum. Not my VE, but my range is going to be maximum if the hole is going to be in between. Okay? And that range, the maximum range, is going to be the capital H. Okay. So I think you understood this thing. Thank you.